everybody, in this video I'm going to be going through the practice exam for the Unit 2 test. So remember, the most important thing on this test is to make sure that you're using the right category of formulas. And the way that you do that is by asking yourself 3 questions. Does the word problem say simple interest? Does it have to do with a savings or a loan situation? And then is it a one-time payment or investment, or is it a repeated payment or investment? And those 3 questions will help you identify which formula set to use. So on question 1, it says, suppose that you want to have $1.8 million saved for retirement in 40 years, and you found a savings account that pays 4% interest compounded monthly. And the question is how much money should you deposit every month to meet your goal? So first of all, I'm going to go through and identify my variables. So the easy variables to identify are that the interest rate is 0.04, the time is 40 years, and the fact that the interest is compounded monthly tells me that K equals 12. And also the fact that I was asked for my monthly deposit also tells me that K is 12. So that information was a little bit redundant in the way that the problem was worded, but sometimes that happens. The other piece of information I was given was the 1.8 million, and that's the amount that I want to have saved for retirement at the end of the 40 years. And so that means that that's going to represent the variable A, because not 40 years, 1.8 million. A is the amount that you have at the end of whatever situation you're looking at. And then the variable that I'm looking for is the variable D, because that's the variable that represents the amount of money I should deposit every month to meet my goal. So those are my variables, and these can actually help you find the formula as well. You can use them instead of the questions, but I'm going to go ahead and go through the process of using the questions. So the first question I ask is, did the problem say simple interest anywhere? And it didn't. It actually specifically said the interest was compounded, and so that means that it's not the simple interest formula. It does not necessarily mean that it's the compound interest formula, though, because savings, annuities, and loans also have compounding interest. It's just a difference of when you're making the payments or investments. So it's not simple interest. And then my next question is it a savings or a loan situation? And because we're saving money for retirement, that means that we can eliminate the loans possibility. So I'm going to eliminate that. And now I ask my last question, which is this a one-time investment that I'm making, or is it one where I'm making repeated investments over time? And since the question asks us how much money should we deposit every month to meet the goal, that means that it's going to be a repeated investment, which means that it's a savings annuities situation. Now, if it had asked how much money should you deposit now to meet your goal, then that would mean that you are looking for P, or you are looking for the initial investment. And so you would have used compound interest in that case. But in this one, we're going to be using savings annuities because of what it asked for. So when we look at these formulas, the one that's going to help us find the amount we need to deposit every month is the main savings annuities formula. So we'll say 1.8 million, that's A, equals the variable D times, in parentheses, 1 plus my interest rate of 0.04 over 12. And this is raised to an exponent of 40 times 12. And then all of that is subtracted by 1. And then all of that is divided by 0.04 over 12. So I'm going to start simplifying by figuring out what 40 times 12 is. And 4 times 12 is 48. So 40 times 12 is going to be 480. Then I'm going to simplify inside this inner set of parentheses by doing my division first, then taking that result and adding 1 to it. So this is the stuff inside of the inner set of parentheses. Then to simplify the outer set of parentheses, I'm going to raise that to an exponent of 480. Get that answer and then subtract 1 from it. And that is everything in the top set of parentheses. So now I'm going to simplify the fraction by dividing by the stuff on the bottom of the fraction. So I'm going to take this answer and divide by, in parentheses, 0.04 divided by 12. Close my parentheses, hit equal. And what I have now is that 1.8 million equals the variable d times this 1,181 point whatever number. And so to figure out what the variable d is, I'm going to divide both sides by this 1,081 point whatever number that I have stored in my calculator. And when I do that, so 1, 8 with 5 zeros after it, divided by the answer that I just found, I get that my monthly deposit needs to be $1,522.89. So that is my monthly deposit. Then for part B, to figure out how much money I need to pay into the account, I'm going to take that deposit amount and I'm going to multiply that by 12 months per year and multiply that by 40 years. And when I do that, so take that answer, multiply by 12 and by 40, that gives me $730,988 and 38 cents. Now the cents might be slightly rounded because I didn't round my deposit amount, but that should be fine on the test if your number is slightly different in that way. Okay, and then to figure out how much interest I'll earn, I'll say, okay, well, I will have $1.8 million in my account at the end, and the amount of money that I put in out of my own pocket was this number that I just found, the 730,000 number. And so if I subtract that from 1.8 million, I end up with $1,069,011.62. 62 cents for my interest earned. And the reason why I earned more interest than I even put into the account is just because this investment lasted for so long. So that's how you do question 1. On question 2, it says, suppose that you invested some money into an account that pays 4.5% simple interest, and by the end of the In question 2, it says, suppose that you invested some money into an account that pays 4.5% simple interest, and by the end of 12 years, your account has $4,620 in it. And the question is how much money did you invest? Okay, so if we go through and identify our variables here, the easy ones to identify is that the interest rate is 0.045, and time is 12 years. And then the 4,620 is the amount of money we have at the end of our investment. So that means that that's A. So 4,620. And then the question is how much money did we invest? And it didn't say how much money did we invest monthly. It just said how much money did we invest. And so that means that we invested all of the money all at once up front. And that means we're looking for P. So that's what that variable would be. And to identify the formula, this one's really easy because the problem did say simple interest. And so that means we're going to use the simple interest formula. And the formula that we'll use is the one that involves both A and P, because we want to find P and we were given A. So to do this, we'll plug in our variables. So the variable A is 4,620, and this is equal to P, which is what we're looking for, times 1 plus my interest rate of 0.045 times the time of 12. So to simplify this, I'm going to see if I can simplify inside of the parentheses. And I can, because I know all of the numbers in there. And to simplify that, I'll multiply my interest rate by 12, because multiplication comes before addition. And then I'm going to do 1 plus my answer. That gives me that number. And basically what I've got so far is 4,620 equals P times this 1.54. So to figure out what the variable P is, I need to divide by 1.54 on both sides. And when I do that, it will cancel out on the right side. Sorry that I don't have a lot of room to write it out. But I'll do 4,620 divided by 1.54. And that tells me that the variable P equals 3,000 when I divide that on both sides. And so that would be the answer for question 2. And again, that came from dividing by 1.54 on both sides. And then on that side, it canceled out. So that's how you do question 2. On question 3, it says, suppose that you can afford a $250 monthly car payment and your bank is offering a 3-year car loan at an interest rate of 2.4%. And we're asked to find how much can you borrow to purchase a new car. So if we identify our variables, the $250 is a monthly car payment, which means that that's going to be the variable D. And then T is going to be 3 because this is a 3-year car loan. And the interest rate is going to be 0.024. And then the question we were asked is how much can you borrow to purchase a new car? So the amount that we're borrowing is the beginning amount of the loan. And so that means that we're looking for P. So if we go through our questions to figure out which formula we want to use, the first question we ask is, does the problem say simple interest? And it just said that we have an interest rate of 2.4%. It didn't say that it was simple interest. So that means we can eliminate that option. And then we say, is this a loan situation or is this a savings situation? And in this case, it's a savings situation because we're getting it's not a savings situation because we're getting a car loan. So we can eliminate the savings annuities option. And then our last question to determine whether it's compound interest or the loans formula is to ask if it's a one-time payment that we're making, like we pay it all off at the end, or if we're paying it off at a regular interval. And in this case, we're making monthly car payments of $250, and so that means it's going to be the loans formula. So the formula we'll be using to find out what P is that first formula. And notice that we need a K here. And so I didn't identify this earlier, but the fact that our car payment is a monthly car payment means that K is going to be 12 because your payment frequency has to match the frequency of however often your interest is compounded. So that's what we'll use for K in this formula. So to figure out what P is, we just need to plug in our numbers. So P is the variable I'm looking for. D is 250. Inside of parentheses, I have 1 minus another set of parentheses where I have 1 plus my interest rate of 0.024 divided by 12, all raised to a negative exponent of 3 times 12. And then all of that is divided by 0.024 divided by 12. So to simplify this, I just need to simplify my parentheses. So inside of these parentheses, my exponent is -3 times 12, which is going to be -36. So that will help me later on in my calculation. And then I'm going to start working on this innermost set of parentheses. So I do 0.024 divide by 12. That gives me that decimal. And then to finish that set of parentheses, I need to do 1 plus my result. That gives me that. Then to do my next set of parentheses, I need to simplify the subtraction and the exponent. And the exponent is going to come first because of order of operations. So I take this number I just got and raise it to a next exponent of -36. And then that result needs to be subtracted from 1. So I'm going to do 1 minus my answer. And that gives me this decimal. Now at this point, I can either multiply by 250 or I can simplify the fraction by dividing by the stuff on the bottom. I'm kind of in the habit of simplifying the fraction first. So I'm going to divide by, in parentheses, 0.024 divided by 12. That gives me that. And then if I multiply that by 250, that gives me the value for P, which was what I was looking for. So the amount that I borrowed at the beginning would be $8,675 and 27 cents. So that's how much I can borrow to purchase a car. And then the next question says, how much money will you pay in total by the time you pay off the car? Well, that's just going to be my $250 monthly payment times my 12 months times 3 years. And when I do that, 250 times 12 times 3 equals $9,000. So I'm going to end up paying $9,000 in total by the end of the 3 years. And the amount that I originally borrowed was $8,675. So to find the interest, I'm just going to take that $9,000 number and subtract $8,675.27. So $9,000 minus the 8675.27 number gives me $324.73 of interest. And so that would be my answer for part C. On question 4, it says, suppose you borrowed $5,000 at a simple interest rate. On question 4, it says, suppose you borrowed $5,000 at a simple interest rate of 6%, and you paid the loan back with $7,100. The question is how many years did you borrow the money for? Okay, so as we go through and identify our variables, the easy variables to identify are that the interest rate is 6%, and the numbers 5,000 and 7,100 need to be identified. So the $5,000 is the amount we originally borrowed, which means that's going to be the value of P. And then the $7,100 is the amount that I paid the loan back with, which is the ending amount. And the question that I was asked is how many years did you borrow the money for? So I'm looking for T. And this question is really easy to figure out which formula to use because it says simple interest. So that means that we're going to be using the simple interest formula. And when we look at these formulas, the one that will be useful is the one that involves A and P because we were given both of these variables. So when I plug those in, I get 7,100 equals 5,000 times 1 plus my interest rate, which is 0.06 times T. Okay, so if I wanted to simplify this, I would simplify inside of the parentheses first, and then I would multiply that result by 5,000. And inside of parentheses, I have multiplication, but I don't know what t is, so I can't actually simplify at all. Because I don't know what t is, so I can't multiply by 0.06, which then means I can't add that to 1, and then I can't multiply it by 5,000. So to solve this, I'm going to work backwards of the order of operations I would use if I knew what t was. So if I knew what t was, my first step would be to multiply by 0.06, then I would add 1, and then I would multiply by 5,000. And that's what would give me the 7,100. So now I'm going to work backwards, and I'm going to undo each one of these steps. So my first step is to divide by 5,000 on both sides. And when I do that, the 5,000s cancel, and I get 1 plus 0.06t equals whatever 7,100 divided by 5,000 is. It looks like that's 1.42. So that undid this first step here. Now I'm going to undo the addition of 1 by subtracting 1 from both sides. And that should give me 0.42 equals 0.06t. And I'll catch up with that on my calculator. And then my last step is to divide by 0.06. And when I do that 0.42 and divide by 0.06, that tells me that t equals 7. And that would be my final answer. I'm sorry that it's a little bit squished in the way that I showed my work there. Maybe I'll kind of separate out my steps so that you can see how that would work. But that's how you would do question 4. On question 5, it says, suppose that you invest $30,000 into an account that pays 20.8% compounded weekly. And the question is how much money will you have in the account at the end of 5 years? So if we identify our variables here, the easy variables to find are the interest rate of 20.8%. The fact that our interest is being compounded weekly means K equals 52. Our time is 5 years. And the $30,000 is the amount that we invest. And it didn't say that we're investing this on a monthly or weekly basis. It just says that we invest it, which means it's a one-time investment that happens at the beginning. So P is going to be 30,000. And the question is how much money will you have in the account at the end of the 5 years? So we're looking for our ending amount. So to figure out our formulas, we'll go through our questions and we'll say, okay, well, did the problem say simple interest anywhere? No, it actually said that it was compounded, which means that it could be any one of the 3 categories that are not simple interest. Then the next question I ask is this a savings situation or is it a loan situation? And since we're investing $30,000, that means it's savings. So it will not be a loans formula. So we can eliminate the loans section. Now we need to ask, is this a savings situation where you're making repeated investments? Or is this a savings situation where you're making a one-time investment? And in this case, the $30,000 is a one-time investment. And so that means that it's the compound interest formula. And we can eliminate the savings annuities option. So in the compound interest formulas, the one that's going to be helpful is the first one because we weren't given the interest and we're asked to find A. So since we know what P is, the first formula is going to be more helpful. So if we plug our numbers into that formula, we get A equals P, which is $30,000, times, in parentheses, 1 plus the interest rate of 0.208 over 52, because that's what k is, raised to an exponent of 5 times 52. So to simplify this, I'm going to first figure out what 5 times 52 is. And it looks like that's 260. So my exponent is equal to 260. And then I'm going to simplify inside of my parentheses. So I'll do the division first, and 0.208 divided by 52 gives me this number. Then I'm going to do 1 plus that answer, which gives me this. And that's simplified all of the stuff in parentheses. Then outside of the parentheses, I have multiplication and an exponent. And exponents go first because of order of operations. So we get that number raised to an exponent of 260. Then we take that result and multiply by $30,000. And that gives us the value of A. So A, in this case, is going to equal $84,700.62. That's the value for A. And then to figure out how much interest we'll earn in 5 years, we're going to use the second formula, which says that the interest equals A, which we just found was $84,700.62, and we're going to subtract the amount that was originally invested, which is $30,000. And when we do that amount minus $30,000, that tells us that the amount of interest we earned was $54,700.62. So that's the amount of interest. Now that might seem like that number is really high, but that also makes sense because the account is paying 20.8% interest, which is a really, really high interest rate. Like that's the type of interest that credit cards usually charge. And so it makes sense that there's a lot of interest that's being earned over those 5 years. So that's how you would do question 5. On question 6, it says, suppose that you deposit $650 every month into an investment that pays 8.5% interest. And the question is how much money will you have in the account in 20 years? Okay, so if we identify our variables here, the $650 is being deposited every month. So that means that's the value of our variable D. The every month piece tells us that K equals 12 because if you make monthly deposits, that's also your compounding period. The interest rate is going to be 0.085 and the amount of time is going to be 20 years. And then the question we're asked to find is how much money is in the account in 20 years, which means we're looking for the amount at the end of the investment, which is going to be the variable A. So you could use these variables to find the formula, but I'm going to go through and ask the questions. So the first question is, does the word problem say simple interest anywhere? And it doesn't, and so that means that it's not going to be the simple interest formula. Then I ask, is this a saving situation or a loan situation? And because I'm investing money, that means that I'm saving money, so it's not going to be a loans formula situation. Then between compound interest and savings annuities, I need to ask, is this a one-time investment I'm making, or is this an investment that I'm making on a regular basis? And because I'm depositing the $650 every month, that means that it's going to be a savings annuities formula. So to use this formula, I'm looking for A, so I'll write down that variable. And then A equals the monthly deposit, which is $650. In parentheses, I have 1 plus my interest rate of 0.085 over 12, raised to an exponent of, 20 times 12. And then all of that is subtracted by 1, and then that is divided by 0.085 over 12. So that's plugging it into the formula. And when I simplify this exponent, 20 times 12 will be 240. Then I can simplify inside my smaller set of parentheses by doing 0.085 divided by 12. That gives me that decimal. And then I'm going to do 1 plus that result. That has simplified the small set of parentheses. And then to finish the big set of parentheses, I need to take that result and raise that to the 240 exponent and then subtract 1. So this number here is basically all of the stuff in this big set of parentheses simplified. Now you could either multiply by 650 or divide at this point to simplify the fraction piece. And I'm in the habit of dividing first, so I'm going to divide by 0.085 divided by 12, and then I'm going to take that result and multiply by 650. But if you had multiplied by 650 before you divided, you would still get the same answer. So either way works. And once I've done that, I find that the amount in the account at the end of the 20 years, is going to be 407549. So $407,000 about. And then the cents is 32 cents. So that's the amount that I have in the account after the 20 years. And to figure out how much money I pay into the account over 20 years, I'm going to use the total deposited formula, which tells me that I have $650, which is deposited every month. So I'll multiply by 12 months and then multiply that by the number of years, which is 20. And when I multiply those together, we get 650 times 12 times 20. And that means that the amount that I paid into the account over the 20 years is $156,000. And so that would be the amount of money I paid into the account. And then for part C, to find the interest earned, I basically say, well, I invested the amount of money I have in the account is $407,549.32. The amount that I put into the account out of my own pocket was $156,000. So if I subtract those two amounts, so 407,549.32 minus that answer I just got, that tells me the amount of interest I earned is $251,549.32. And that's the amount of interest that I earned. And that's using that last formula for interest. So that's how you would do question 6. On question 7, we're asked to find what number is 35% of 480. So if you set this up as a two equivalent fractions problem where you have one fraction that represents your percentage, so 35 hundredths, and then we're asked what is 35% of 480. So that means we're looking for the number that corresponds to 35%, and the whole that we're trying to find 30% of is 480. So that's how you would set up the fraction, and then you can calculate it by cross multiplying. So 480 times 35 gives you 16,800, and this is equal to 100 times x. And so if we just divide both sides by 100, that's going to tell us that x equals 168. And that's one way that you can calculate it. It's not the only way. Some people might also solve this problem by doing 0.35 times 480. That would also work. So it's kind of up to you to decide how you want to solve that percentage problem. On question 8, it says, suppose you get a 5-year business loan for $24,000 at an interest rate of 3.5%, And the question is what is your monthly payment? And notice that it's a monthly payment, which is going to tell us that K equals 12. And then we can also find our other variables where T is 5. The interest rate is 0.035. And the 24,000, we need to decide what variable that is. So it's the amount that we're getting a loan for, and that amount is going to be borrowed at the beginning of the loan. And so that means that this is the value of P. And then since we're looking for our monthly payment, that means that we're looking for the variable D. So to identify which formula we're going to use, let's start with our first question. So we start off by asking, is this a simple interest problem? Does it say simple interest anywhere in the problem? And it doesn't, so that means that it's not going to be simple interest, so we can eliminate that one. Then we ask, is this a situation where we're saving money, or is it a borrowing or like a loan situation? And in this case, we're getting a business loan, so that means that we're definitely not doing the savings annuities one. And then the last question is, are we paying back this loan with a one-time payment, or are we making repeated payments? And since we were asked what our monthly payment is, that means that we're making repeated payments, and our problem is going to be a loan situation. So we'll go ahead and use the loans formula, which says that P, which is our $24,000, equals the variable D times, in parentheses, 1 minus, in another set of parentheses, 1 plus, our interest rate of 0.035, divided by 12, all raised to a negative exponent of 5 times 12. And then all of that is divided by our interest rate of 0.035 divided by 12. So to simplify this, I'm going to start by simplifying my exponent, and 5 times 12 is 60. So the exponent is going to be a negative 60 because it was negative 5 times 12. And then I'm going to start working on this small set of parentheses. So the division in that small set of parentheses, if I do 0.035 divided by 12, that's going to give me this decimal. And then I'm going to do 1 plus that answer, which gives me this decimal. And now I can start working on the big set of parentheses. So in that big set of parentheses, I have an exponent and subtraction, and exponents always go first. So we're going to raise this to an exponent of negative 60, and then we're going to do 1 minus that result. So that gives us that number. And then to simplify the fraction and the division by the stuff on the bottom, I'm going to divide this by 0.035 divided by 12 inside of parentheses. And so basically what I've got so far is that 24,000 equals the variable D times this 54.96, etc. number. So to figure out what the variable D is, maybe I'll do this in green. We're just going to divide both sides by 54.96, this decimal that I have in my calculator. And when I do that, so 24,000 divided by the answer I have, that tells me that my monthly deposit should be $436.60. And I apologize, that's not the monthly deposit, that's the monthly payment. Sometimes I accidentally call it a deposit because it starts with a D. But that's what our monthly payment would be for this business loan. And then the amount of money that we'll pay in total is going to be that monthly amount times 12 months times my 5 years. So if we take this amount, multiply by 12, multiply by 5 years, that says the amount of money that we will pay in total is $26,196.11. And that is a reasonable number because the amount that we originally borrowed was $24,000, and the amount we have to pay in total is going to be the full loan amount plus a little bit of interest. And the way we figure out how much interest that is we take the 26,196 number that we just found, subtract the 24,000, and when we do that, that tells us that the amount of interest we'll pay will be $2,196.11. And so that's the amount of interest that we will pay. And that's how you would do question 8. On question 9, it says, if you lend a friend $2,000 at a simple interest rate of 3% for 4 years, how much interest will you earn? So the question is how much interest will we be earning? So to identify our variables here, the $2,000 that we have is the amount that we lend to our friend. So that lending is happening at the beginning of the situation, and so that means that that is P. Then the interest rate is going to be 0.03, the time is going to be 4, and the question is how much interest will we earn? So we're looking for interest. So if we go through our formula questions, our first question is, does the problem say simple interest anywhere? And it does, and so that means that we're just going to be using a simple interest formula. And when we look at the simple interest formula, the one that's going to help us in this situation is the second one, because that's the one that involves I. And to find that interest, we're going to basically just plug in our numbers. So we get I equals P, which is 2,000, times R, which is 0.03, times T, which is 4. And when we multiply all of those together, 2,000 times 0.03 times 4 gives us 240. And so that would be the amount of interest that we would earn for question 9. And then on our last question, question 10, it says, suppose that you use $11,143.25 to pay off a 3-year loan with a 5% annual interest rate compounded quarterly. And the question is how much money did you originally borrow? Okay, so let's figure out our easy variables first. So T is 3 because it's a 3-year loan. R is 0.05 because the interest rate is 5%. And since it's compounded quarterly, K is going to be 4. Now, the $11,143.25, that's the amount that we're using to pay off the loan. And it doesn't say that we're paying it off every month with that amount. That's basically the amount that we're paying off all at the end. And so that means that that number is going to be A. And then the question is asking us how much money did we originally borrow, which is the beginning amount. So we're looking for P. So to identify our formulas, let's go through our questions. So the first question is, does it say simple interest anywhere? And it doesn't. In fact, it specifically says it's compounded. But remember, compound interest can be any one of the other 3 categories. So the next question I ask is this a saving investment situation or is it a loan situation? And since we're paying off a loan, that means that it's definitely not a saving situation. So we're going to eliminate that one. And then our next question is this a situation where you're paying off the loan one time, or is it one that you're making repeated payments? And since they told us the total amount that we paid off the loan in one big lump payment, that means that we're going to be doing the compound interest formula. So when we look at these 2 formulas, the one that's going to be helpful for part A is the first one. And when we plug in our numbers for that, we get $11,143.25 equals the variable P, which is what we're looking for, times 1 plus the interest rate of 0.05 divided by 12 raised to an exponent of 3 times 12. So to simplify this, I'm going to first simplify my exponent. So 3 times 12 is 36. And then I'm going to start working on these parentheses here. So I'll do my division first. So 0.05 divided by 12, that gives me that number. Then I'm going to add that to 1, which gives me that number. And then I'm going to raise that to an exponent of 36. So all of this stuff that I've calculated in my calculator gives me 1.1614, etc. And that number multiplied by P equals my $11,143 number. So to figure out what P is, I now just need to divide both sides by this decimal number that I found. And when I do that, $11,143.25 divided by the answer I have stored in my calculator tells me that P equals $9,594.07. So that's what P is. And then the interest that I end up paying, I can calculate with my second equation. So interest is going to equal A, which was the $11,143 number. And then I'm going to subtract P, which is the number I just found. And when I calculate that out, 11,143.25 minus my answer, that gives me $1,549.18. So that would be my interest amount. And that's how you do all the questions on the practice test. If you have any questions, please let me know.